So here we go. We're on page 44. Look at this very first one. What is the domain of this function? So when we talk about domains, what are we talking about? Your x values. So the first thing we would do on this is to look at what? The graph. So let's graph it. Y equals, and in my graph, I'm going to put square root of 4 minus x. Okay? So here's the picture of the graph. So I want to know what x values does this cover. So I'm going to start, it goes to negative infinity up to what? To 4, right? So my x values are negative infinity to 4. So look at my choices. If I wanted to write negative infinity to 4, it would be B. X is less than or equal to 4. So anytime it says domain, that's what we're looking at. Okay? The range is your y's. How far up, how far down it goes. Yep. All right, so let's look at the next one. Which intervals correctly define the domain of, and it gives us our equation. So we're going to put that in our y equals. So everyone put that in your y equals. So y equals, clear that out. Now you can either use your fraction button or make sure you put the denominator in parentheses. I'm going to go ahead and use my fraction button. So I have 1 over x plus 4. Now look, it's very important that you hit your right arrow key so that I can put my minus 2. So that's what it should look like. Right here. Yep. Okay, so you see this break? There's where I have a vertical asymptote. Okay, so I have an asymptote here. So my domain would be everywhere except I have a break. Well, where do I have a break? At negative 4. Okay, so if I want to choose the ones that are everywhere except negative 4, which one would that be? This says negative, okay. Was it negative 4 or positive 4? My asymptote. It was negative 4, so it has to be C. So this says that it goes from negative infinity to negative 4, and then negative 4 to infinity, but it doesn't include negative 4 because they use the parenthesis instead of the bracket. If they use the bracket, that means it includes negative 4. So my answer is C. All right. Okay, this one, let me make this a little smaller so we can see all of the graphs at the same time. Okay, whoops. All right, so in this problem, it says, which graph corresponds to the given constraints? So look at what it says. They said I have a domain of x is greater than 0 and x cannot equal 2. So let's mark out the ones that don't follow that rule. My domain is greater than 0. So which two graphs can I cross out because the domain does not show as only greater than 0? So my x values, because this is what it says, x has to be greater than or equal to 0. So look at A. I can cross out A because don't my x values, I have part of my graph over here at negative 3, negative 2, negative 1. So I know it can't be that. What's the other one? D. Can't be this one. All right. Now, B and C are all, my x values are all greater than 0. Okay, but now look at my range. It says my range is between negative 3 and positive 3. So which one of these shows that graph? It's B. What would be my range for graph C? 0 to infinity. And they probably have a bracket there. Okay? All right, so those weren't too bad. We kind of like those. All right, next one. This is our last domain question. Which function has the fewest domain restrictions for real numbers? All right, so let's talk about what that means. The fewest domain restrictions means the fewest amount of breaks in the graph. That kind of makes sense, right? So I would graph each one of these and see which one has the fewest breaks in the graph. So I want everyone to do that. It'll take a little bit. It doesn't take very long. Okay, so graph A, graph B, graph C, and then pick the one that has the fewest amount of vertical asymptotes or the fewest breaks in your graph. That's okay. It'll still work for a little bit. Okay. And some of them may have the same amount of breaks. So you know that those probably can't be your answer, right? Because they want the one with the fewest domain restrictions. All right, so when you graph these, your graph probably looks something like this. Your first two graphs look like that. Your second one, I don't know what it looks like. It may look something like this. Okay, it has two breaks. But this one is what? Something like that? But it's a parabola. So what is my domain for a parabola every single time? All reals. Negative infinity to infinity. So which one has the fewest domain restrictions? D. Okay? All right. Okay, so the next part starts talking about inverses. So do you remember how to find the inverse? That was chapter 6. We found inverses by switching our x's and y's and then solving for y. So look at this problem. I actually have f of x stands for my y equals x plus 1. So now to find the inverse, I have to switch my x's and y's. So now I have x equals y plus 1. And now solve for y. So y would equal x minus 1. So which one's my answer? B. So to find the inverse, switch your x's and y's, solve for y. Okay, the next one. We talked about this in class, but we didn't graph the inverses. Which statement about graphs and their inverse is true? And I told you this when we went over this. I don't know if you remember. When you graph the original graph and its inverse, is the inverse symmetric about y equals x, symmetric about the origin, the x-axis, or the y-axis? Do you remember which one it is? It's the line y equals x. Okay? So when I have a graph and I graph its inverse, here's the line y equals x. They take your original graph and they flip it about that line y equals x. Okay? So inverses are symmetric about the line y equals x. Okay, so let's look at this one. Which function is the inverse of f of x? They want us to find the inverse. So what did we just say? How do we find the inverse? Okay, so I have y equals x plus 4 quantity squared. Switch your x's and y's. X equals y plus 4 quantity squared. If I want to solve for y, what do I have to do? Huh? take the square root of both sides. So I'm going to take the square root. Now, over here it's important. When I take the square root of x, since it's a variable, I have to have plus or minus the square root of x equals y plus 4, and then subtract 4. So really I have negative 4 plus or minus the square root of x equals y. Now, look at what this says. Which function is the inverse? If this is my answer, this is not a function. The reason it's not a function is when I plug in a value for x, I'm going to get two different answers. Okay, when you have a function, you can only have one answer. So my answer is actually D. Okay, so on that one you have to be careful. A lot of people wanted to put A, because that kind of matched up to my answer without the plus or minus. Okay, but this is not a function. Okay, next one. Which graph represents the inverse, of f of x equals 2x? So the first thing I want you to do is find the inverse. Okay, so find the inverse. And we find the inverse. I have y equals 2x. So now when I find the inverse, I switch my x's and y's. So when I solve for y is x over 2. That's my inverse. So they want to know which one of these shows the graph of this inverse. So now you can either plug it in or you might can tell just by looking at it. Which one is it? B. Okay, so first find the inverse. After you find the inverse, graph that answer. Okay, the next problem, I like this problem because it has a lot of words in it. There's not even any numbers. This is probably the easiest problem in the entire packet. Okay, and a lot of you would look at it and say, I don't want to answer this, circle an answer and go on. Don't do that, because sometimes the easy ones look hard, but they're really not. Okay, so look. Profits P are equal to sales S minus expenses. So they're wanting us just to write down what we're reading. So I'm going to write it down as I see it. So P is equal to sales minus expenses. Expenses are equal to T plus M. Which system of equations models this situation? It's A. So see how easy that was? And most of you, if you looked at it, you would have said, oh, this is going to be too hard. I'm going to skip it and go on. I'm just saying. In case you're tempted to do that, don't. Okay. So let's look at this one. This one is the same type of problem. It looks like it might be hard, but it's actually very easy. So let's look at this. Tyrone spent no more than $1,500 to buy a television and a DVD player. He spent at least 4 times as much for the TV as for the DVD player, and the television and DVD player each cost at least $100. Which system of inequalities models what he spent? So look, I know that he bought, in this first sentence, a TV plus a DVD player, and he's going to spend no more than $1,500. So no more than would be what? Less than or equal to. So that has to be less than or equal to $1,500. Okay, so let's look at A. Could this be A? Can't be my answer. They have greater than. Okay, what about D? Can it be D? No. So now I'm down to 2 answers. Now look at how they wrote those. They just said that the T, the television plus DVD, is between 0 and 1,500. Is that okay? Yeah, that's fine. All right, so now let's look at our next sentence. He spent at least 4 times as much for the television as for the DVD player. So for the TV, he spent 4 times as much. Okay, so 4 times as much. TV is what? 4 times D, and it was at least. So at least is greater than or equal to. So which one does it have to be? Automatically C. See how easy it is? Okay. All right, the next one. Okay, in this problem, now this is kind of a long problem, and there's lots of different ways that you could work this. First of all, let's sketch the triangle. It says vertices of a triangle are 2, 1, 4, 4, and 6, 2. All right, so let's just make our own little, see, 1, 2, 3, 4, 5, 6. Mine's lopsided. 2, 3, 4. So I have the point 2, 1. I have the point 4, 4. And I have the point 6, 2. So what they want to know is which system of inequalities describes the interior of the triangle. So what they're saying is when I shade this triangle in and I pick a point in this shaded region, which of these three or which inequality would work? So what we're going to have to do is pick a point on the inside of that triangle and plug those values in. So if I pick 4, 2, 4, 2 is right in the inside. So I'm going to use the point 4, 2, and I have to plug it into each one to see if it works. Okay, so where do you want to start? A, B, C, or D? Okay, so let's start with C. This first inequality says 2 times 2 is greater than x, which is 4. Is that true or false? It's false because 4 is not greater than 4. Okay, which one do you want to try now? A? All right, so here's A. 4 times y is greater than 4 plus 2. That's true because 8 is greater than 6. So now that one checked out. Let's do the next one. 3 times 2 is less than 2 times 4 minus 1. So that's saying 6 is less than 7. Is that true? Okay, so that one worked. Now this one is saying y, so 1 is less than 8 minus 2. Do I have that? Oh, no, sorry. I was looking at the wrong. I was using the point 2, 4. So 4 is less than 8 minus 4, 2. I'll eventually get it. So 2 is less than 8 minus 4. That's true. Oh, but that's a problem. Because that's not my answer. Did I mess up somewhere? 4 times 2, 4 plus 2, 3 times 2, 2 times 4. I worked this differently the first hour. I thought, no, I'm going to try it this way because it's going to be easier. B is my answer. Okay. All right, here's how I worked it first hour. We graphed each of these inequalities in our calculator and saw which one formed this triangle in the first quadrant. Okay, but it was kind of hard to tell by looking at the graph if it actually matched up to our triangle or not. Okay, the three overlapped shaded areas is what should form my triangle. Okay, and B, when I graphed it, it did look like this triangle with all three shaded regions intersecting here. Okay, but it should work also that if I choose any number, you know what, I'm guessing what our problem may be. See how off my graph isn't exactly the best graph in the world. Is the 0.42 inside that? I know, but see this line right here? See, this line is connected to 3. So I bet the 4-2 is not actually inside my triangle. You just can't tell by looking at it. Do you see what I'm saying? So if I were to really graph this, let me show you. Okay, if I graphed, let me get, because it's crooked, let me get a good, okay. So let me just graph this really quick. If I have the point 2, 1, so 1, 2, there's the point 2, 1, and then I have the point 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, and I have the point 6, 2, so 2, 3, 4, 5, 6, 2. And I choose the point 1, 2, 3, 4, 2. Yeah, it should work. Okay, I'll have to look at it. We'll come back to it though. Okay? The correct answer is B. And when we graphed it, it does show it. But you're not going to be able to graph inequalities because it's going to be too, unless you do it on your calculator. Okay? I'll show it. Put a point in. Huh? No. Mm-mm. All right, yeah, I'll look at it and see which way is the best way to do it. No. Okay, let me get back to, let's go to the next one. I don't know why it's doing that. I'll look at it. It's probably something easy. Okay, this is one. I like this problem. This is an easy problem. Sunny's already shaking her head no. Okay. So look, Meredith invests $50,000 in her new business. It costs the company $10 to produce each unit, which is sold for 15. Let C represent the cost and R represent the revenue for X units. Which statement is true about the graphs of the equations? So they just gave you two equations. They're asking you what's true. Look at A. Both slopes are positive. So look at my two equations. True or false, are their slopes positive? That's my answer. Which knows my slope? My slope is always the number when it's solved for y with the x. That was easy. We like that. They threw in all those numbers just to make us think it was hard. Okay. Which quadrants contain the solutions to this systems of inequalities? So we are going to graph these, and we can actually graph the inequalities where it's going to shade for us. And then we're going to see which quadrants do our shaded regions overlap. And remember, your quadrants are labeled 1, 2, 3, and 4. Okay, so we need to solve these first for y. So my first one's pretty easy. It would be y is less than or equal to 2x minus 3. My second one, I would have 3y is greater than or equal to negative 4. And then divide by 3. So y is greater than or equal to minus x. So negative 4 minus x over 3. So are we good with those? Here's my first inequality. Here's my second inequality. So now we're going to graph these and see what regions, which quadrants my shaded area overlaps. So let's put these in our calculator. Y equals, okay, I'm going to show you. Okay, first of all, my first equation or inequality was 2x minus 3. Now, I need to shade this. It is less than, so would I shade above or below? Below, less than would be below. So look, I'm going to put my cursor right before my Y, and I'm going to press enter until it shows me that it's shading below the line. You see it? So now I had to press enter, I think it was 4 times, and that's what I got. So now I'm going to go down to Y2. Y2, the equation is negative x minus 4 over 3. So you need to either put parentheses around that top or use your fraction button. And then it's greater than, so I'm going to go before my y, and I'm going to press enter until it shows that it's shading above. And then this one is negative x minus 4 divided by 3. Okay, I'm going to graph it. And I want to know, where do my two shaded regions overlap in what quadrants? Okay, 1. This is quadrant 1. This is quadrant 4. So 1 and 4. Okay, so far so good? Okay. What is the solution to this system of equations? So let's look at it. There's lots of ways we can solve these. Okay. One way is to take each of my choices, my x and y, plug them in, and see which one gives me a true equation. That's one way. The second way would be to solve for y on each of these, graph them, and see where they intersect. Where they intersect would be my answer. I could also solve by elimination, solve by substitution, lots and lots of different ways. So, do you want to just substitute the numbers in? Okay, so let's try A. A, I would have 3 times negative 1 minus y, which is negative 2, plus 5, and I'm supposed to get 0. So that would mean negative 3 plus 2 plus 5 equals 0. That's not going to work, so I automatically can cross out A. So now let's try 3 times negative 1. Oh, okay. So now I'm going to try B. So I'm going to say 3 times negative 1 minus y, which is 2, plus 5 equals 0. So negative 3 minus 2 plus 5 equals 0. Did that one work? Yes. Okay. Now I have to try, so it worked for the first one. Now let's try the second one. 2 times x was negative 1, plus 3 times y, which is 2, minus 4, supposed to equal 0. Negative 2 plus 6 minus 4 equals 0. Is that true? Yep. So my answer is B. Okay, the next one. What is the solution to this system? What are you going to do? Same thing. This time I have an x, a y, and a z. When you have ordered pairs like this is x, this is y, this is z. So you're going to plug those in, see which one works. Okay, so I want everyone to plug those in. If you do, instead of working out like we did, just substitute them in, just like we are this one. Which one? Okay, Matt says it's D, so let's check it. So x plus y, so negative 2 plus 7 is supposed to equal 5. That's true, it did. Then this one says negative 2 plus z, which is 8, which is 9, is supposed to equal 7. That's true. And then y plus z, 7 plus 9 is supposed to be 16. That's true. So my answer is D. Yay! I know, it's so much fun, isn't it? I love it. I love it. Just keep telling yourself. We love reviewing for the EOI. Okay, this one, what do you think? Easy or hard problem? So this is one of those easy problems that you should always read through and always do, right? So look at it. Amy ordered K ketchup packets, M mustard packets, and R relish packets for the concession stand at school. She ordered twice as many mustard as relish and 100 more ketchup than mustard. She ordered a total of 1,000 packets. The situation can be modeled by this system. So they did the hard part for you. They gave you the equations. How many relish packets did Amy order? So what am I solving for? K, M, or R? I need to solve for R. So I need to go to the equation that has R in it. Now, this is K plus M plus R equals 1,000. Well, do I know what K is? It tells me K equals, so K is 100 plus M, okay? Yeah. Well, so right now I'm just plugging stuff into this one. I know what K is. I know what M is. What is M? 2R plus R equals 1,000. Okay, so now I need to get rid of this M. I'm going to put M is 2R, right? And you could do that in the first step if you wanted. So 100 plus 2R plus 2R plus R equals 1,000. Okay. All right, so here's my equation, right? So K is 100 plus M. Plus M plus R. Now I need to replace M with 2R. So I have 100 plus 5R equals 1,000. 2 plus 2 plus 1. Subtract 100, 5R equals 900. Divide by 5, and what do we get? R, which is 900 divided by 5, 180. Subtract 100, divide by 5. All right, let's go. You guys need to focus. I'm losing you. Huh? All right, look at this one. We like this one. How many real roots does this function have? Think. A real root is where what happens? Does this ever cross the x-axis? Nope. So real roots where it crosses the x-axis. A. All right, which equation has -1 and 3 as solutions? Which one has -1 and 3 as solutions? Lots of different ways we can solve this. Okay, 2 ways I can do this. I can graph each one of these and see if it crosses at -1 and 3. I can take -1, plug it in, 3 and plug it in, and see which ones work. I can put this in my y equals, go to my table, plug -1 and 3 in, and I should get 0. So there's lots of different ways we can do this. You can plug and chug if you want, okay? Here's probably what I would do. First of all, if you're going to plug and chug, if I'm going to do A, make sure when you plug in -1, you put parentheses around that. So when I plug -1 into A, I get 1 plus 2 minus 3, and it's supposed to equal 0. Does that equal 0? So when I plug 1, yes, but now I need to plug in 3. So 3 squared minus 2 times 3 minus 3 is supposed to equal 0. Does this equal 0? 9 minus 6 minus 3. Yep. So A is my answer. So you can plug them in. If I were to graph this, it would cross the x-axis at -1 and 3. Okay? Lots of different ways I can do that. You want a color on my board? Oh, it's kind of hard. What number is added to both sides of the equation to solve by completing the square? Remember completing the square? Here's what we did. We always took half of our x term, so what's half of 8? 4, and then we did what? Take half of 4 and, half of 8 and square it. So 4 squared is 16. When completing the square, you take half of your x term, square it, and you add that to both sides. So 16. Would I ever get a negative number after I square something? If you square something, you're always going to get a positive answer. All right. What is the solution set of this equation? Okay, I'm going to show you 2 different ways to do this. All right. Here's the first way. I'm going to put this, first of all, the solution would be when I graph this, it has to cross at my points. That's my answer. Well, it's going to be kind of hard to tell when I graph it if it crosses at 3/5, right? So I'm going to put this in my y equals, and then I'm going to go to my table. Now, the other thing I could do is plug and chug, just like we did the other ones. But a lot of times you guys don't like dealing with fractions, okay? So I'm going to show you the calculator way first. So in my y equals, okay, my y equals, I need to put in 10x squared minus x minus 3. And I need to get rid of this little inequality over here. So I need to press enter. Come on, enter, enter. So I get back to my little line. All right, so I'm going to graph this. Now here's why it's kind of hard to tell where it crosses. That's kind of hard to match up to the numbers that they have. So instead of looking at the graph, I can go to my table, second table, and I'm going to just start in plugging in A. My first value that they told me was -1/2. So I'm going to type in -1/2, and I should get 0, right, when I plug it in. And I did. What's my next number I'm going to plug in? 3 divided by 5. And I got 0. So does A work? Yep, A works. So I can use my table. If you don't like to use your table, you can substitute those numbers in, just like we did before. And then you can plug this in your calculator, and you should get 0. And if that one works, then you would plug 3/5. Just like this, and see which one works. Okay, so either way you can do that. Doesn't matter.